Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning about coordinate reflections. And let's get started with the following problem. Let point A be the coordinate 4, 3. Let B have coordinates of -2, 1. And point C have coordinates of 1, 6. Be the vertices of triangle ABC. Sketch and find the coordinates of triangle A prime, B prime, C prime, their images after reflection over the line x is equal to 5. So the first thing you want to do here is plot the points in a coordinate grid. And then think about, okay, how does the line x equal to 5 look like? It is indeed a vertical line at x is equal to 5 as shown here. So here are the points that are plotted, and here's x is equal to 5. Now, according to this, where would point A be located? Well, it will be located right at that point, and that's actually A prime. So similarly, we want to sketch point B, the image of point B. So if you count the distances here, so we are 2, 4, 6, 7 units away from the x-axis. So we move 7 units to the right after the x-axis to be located over here. So that will be B prime. And finally, we move 4 units to the right from the x-axis to locate point C prime, okay? So if you do all this, you should obtain the following image of triangle ABC. So what is the notation in this case in terms of lowercase r? So let's analyze this further. So here we can actually write all the points using the notation. For example, lowercase r, and we're actually reflecting each point over the x is equal to 5 line. So you write r lowercase x equal to 5, and now you write the first point. So in this case, the first point is actually coordinates 4, 3. Okay, so this becomes equals to, and now the points here are going to be what? 6, 3. Okay, maybe there's something you can notice here already. So if you compare the x values, first of all, the y values are going to be the same, right? But here we have x equal to 5. So what that means is that here we're adding 1 unit, and then from 5 we're adding another unit. Basically, that means that these points have to be equidistant. So you could calculate these as well if you want to. So the next point would be r sub x equal to 5. And then we have the point which is located at -2 here from the diagram. Again, this is 1 unit, this is -1. And then we have 1 unit above. So if you reflect that over, we actually get a point B prime, which is located at 12, 1. Again, if you compare these two, if you add them up, you end up with 10, and then divided by 2, you end up with 5. And that is the x equal to 5 line. And finally, for the third point, point C, maybe I should label these and write A. So this is point A, this is point B, and this is point C, okay? So r sub x equal to 5, and here we have x equal to 1 and y equal to 6. That gets mapped onto 9, 6. And again, you can see the equidistance here, right? So 8 units away, and basically you have to add 4 units to get from 1 to 5, and then from 5 you add another 4 units to get to 9, okay? So in general, you can also write that you're reflecting the entire triangle ABC over x equal to 5 to obtain triangle A prime, B prime, and C prime. So that's basically how you would write this in geometric notation, okay? Using reflection. Now, generally speaking, when you have reflections, it's always a good idea to look at the general cases, because that might help you to solve certain problems faster and in a more efficient way. So let's see what I mean by that. So here's some general cases. What are the coordinates when you reflect a point xy over the x-axis, or over the y-axis, or over the y is equal to x line, or what happens if you reflect x comma y over the line y equal to negative x? So at this point, if you would like, you can pause the video and try this out. So let's do the first one. So let's say you have a point. Let's assume the point is located somewhere here. Let's call the point 2, 4, okay? There you go, point 2, 4, okay? So we are going to reflect it over the x-axis, okay? So if you reflect it over the x-axis, it actually goes down by the same amount of units. And there you go. So in this case, P prime is going to be the same x value, but -4, okay? So in the first case, if let's say you're reflecting it over the x-axis, then what will be the points here in this case? So let's write them in here. So the x is going to stay the same, but now it's going to be -y, okay? Now we can repeat the same thing for reflecting x comma y over the y-axis. Now if we reflect it over the y-axis, then you would expect now that the x value changes. As a matter of fact, it becomes negative, but now the y value will stay the same. So in this case, it's going to be -x comma y. And what about the other ones? Well, let's draw the y equal to x line, okay? So the y equal to x line is just simply a 45-degree line here, okay? So let's make the ruler at 45 degrees. There you go. So that is y is equal to x, okay? Now we're reflecting that point over, okay? So if you reflect that over, remember that this is going to be now the perpendicular bisector, the y equal to x line. So that means you end up here somewhere, P prime. And what are the coordinates here? Okay, so the coordinates are going to be 4, 2. Now, does this always work even if you're in the negative area? For example, what if the point is here? Let's call it point Q, okay? And that point is now -2, 2. What's Q prime? Well, in this case, the Q prime point is going to be at 2, -2, okay? So what do you notice here? What happens here in this case? Well, it seems like that you're actually swapping it out, okay? So it seems like that here this becomes y, x, okay? Is this always the case? The answer is yes, it's always the case, okay? So let's analyze the last scenario if you reflect a point over the y equal to -x line. So here's the y equal to -x line. And let's say we're reflecting the point 2, 4 over that line. And as a matter of fact, this now becomes the perpendicular bisector of that. So let me kind of draw this in at also 45 degrees. Let's get it at 45. There you go. So that means, let me draw this dotted. There you go. So it should go over here somewhere. Okay. There you go. Okay. Now this becomes, again, the perpendicular bisector. So we have these two are congruent. And we have P prime right here, okay? So what are the coordinates here? So the coordinates are going to be -2 and -4. So what do you notice here? So now we notice, actually this should be, so the points here are going to be, so P prime is going to be at -4, -2. So what do you notice here? That not only x and y is swapped, but also negated. So as a matter of fact, this becomes -y, -x. And that's basically it, okay? So these are the general formulas for the reflections, okay? This is something you need to know for the Regents exam if you ever take a Regents exam in geometry, but also for your homework assignment. So let's look at another example now. we're going to take the same coordinates from the do now, and now we want to find the coordinates of triangle A prime, B prime, C prime, the reflection of triangle ABC over the x-axis. And then after that, we're going to let triangle A double prime, B double prime, and C double prime be the image of the triangle A prime, B prime, C prime after a reflection in the y-axis. What are the coordinates of A double prime, B double prime, and C double prime? Well, let's look at it. Here we have a reflection first over the x-axis, okay? So here are the coordinates, A prime, B prime, and C prime. Now, after that, we wanted to reflect the new coordinates over the y-axis. And we saw the generalization here. Once you reflect it over the y-axis, what do? You actually need to swap the points. Okay, so here are the new points. Now, if you look at the original coordinates A, B, and C, and the coordinates A double prime, B double prime, and C double prime, how are these points related? Well, it turns out that these points are related by something called a composition of transformations. So let me first define the composition of transformation. A composition of transformation is two or more transformations occurring in sequence. You can think of it this way. Let's say you input a rule into a machine to transform certain points, and the output is, for example, A prime, B prime, and C prime, right? Now you take those points from the output and input them into another machine, another rule, which is the reflection over the y-axis, and the output will be A double prime, B double prime, and C double prime. And that is actually called a composition of transformations. So how do we denote a composition of transformation mathematically? So the way it works, and I'm going to show you the example here, that we first had a reflection over the x-axis of triangle ABC, but then we reflected that triangle over the y-axis, okay? So there are a few things that you can notice here. Actually, let me also write that this resulted in triangle A prime, B prime, and C prime. Now here are a few things to be said, okay? So let me use a different color. That first of all, that this dot or circle represents composition. And another thing to notice here, that you're actually reading it from right to left, okay? So from right to left, okay? So you can actually have more than two, okay? And you would just keep adding here on going to the left side, okay? You can also rewrite the composition of transformation as follows. You can, for example, write R x-axis, and then you open parentheses, and you can write R y-axis. And then you open another parentheses and write triangle ABC, and then you have to close parentheses twice, and that results in triangle A prime, B prime, and C prime. It's kind of like saying, okay, we have a reflection over the x-axis of the reflection over the y-axis of triangle ABC, okay? So these are the two different notations, this one and this one. What I've seen the most on Regents exam is the first type of notation, okay? So let me show you an example now. So here are two examples. The first one, what are the coordinates of, now we're transforming the point 2, 5, you're first reflecting it over y equal to 3 line, and then over the x equal to 4 line, okay? So the first thing we want to do is actually draw these in. So here we have point 2, 5 and the line y equal to 3. So if you reflect that over first, you end up here, right? So the new coordinate, and let me call that point P, and this is going to be P prime, is still going to be at 2. but now it's going to have a y coordinate of 1, which makes sense because 1 and 5 are both equidistant to y equal to 3. The next thing was reflecting now point 2 comma 1 over the x equal to 4 line. So let's draw that in. So here's the x equal to 4 line, and then we reflect it over to p double prime. And as you can see, we have x coordinate of 6 and y coordinate of 1. So the first one, the answer is equal to 6 comma 1. As you can see, we read the point from right to left here, okay? And now for the second part, it says that first we're reflecting over the y equal to x line. So when we go back, you remember the rules, okay? When we reflect over the y equal to x line, what we do, we just swap the y and the x. So that means that the first transformation, so let's write this here, y equal to x of point 2 comma 7 is going to be 7 comma 2, okay? Now we're reflecting that point 7 comma 2 over the y is equal to x line again. And what happens here, we have to swap them again and we end up with 2 comma 7. So the answer here is actually the same thing. So that means that in this case, when you have a composition of the same transformation twice, you actually end up that the image is equal to the pre-image. So let's look at one final example. Now it says here, reflect the point 3 comma 5 over the line y equal to 2x plus 4. So again, the way you would write it is this r lowercase y equal to 2x plus 4 of point 3 comma 5, okay? So the first thing you do is graph the line 2x plus 4 first. So here we have the line of 2x plus 4. So let me label that really quick. Y equal to 2x plus 4. And we have the point 3 comma 5. So obviously if we reflect it over, what happens here is that y equal to 2x plus 4 is going to be the perpendicular bisector of the segment joining this point, let's call it point A, and A prime over here, okay? So if you have a point here, it's going to look like that, and that's the perpendicular bisector. Obviously, it's not drawn to scale yet. So how can we algebraically find that point? Well, we're going to use the knowledge we have about slopes and midpoints and distance formulas. So let's do that. So here we know that the original line for which A is being reflected onto has a slope of 2. So that means that segment, let's say A prime, will have a slope. So the slope, let me denote it M, which is equal to negative 1/2. So it's the negative reciprocal, okay? So at this point, what else can we say here? Well, we can say that the line, let me call it y sub A prime, okay, the line defined, or the equation defined by segment A prime is equal to negative 1/2 x plus b. So how do we find the b value? Well, we just substitute these points into the equation. So here we have 5 is equal to negative 1/2 times 3 and then plus b, okay? So what we can do here is, for example, write 5 is equal to negative, so this becomes negative 3/2 plus b. And at this point, it's probably a good idea to change the 5 into a fraction, namely 10 over 2, okay? So that means that the b value is going to be, if we add both sides with 3/2, 13 over 2, okay? Which is about 6.5, which makes sense, which is somewhere here, okay? So it does go through that. So that means that the equation of the line of segment A prime is equal to negative 1/2 x and then plus 13/2, okay? So how do we find the point of intersection with that line? Well, we want to set this equation equal to this equation, right? Because they share the same y-intercept, so we want to solve for that. So we write 2x plus 4 equals to negative 1/2 x plus 13 over 2. So the first thing we should do is multiply both sides by 2. So you end up with 4x plus 8 is equal to negative x plus 13. So let's add x on both sides. We get 5x is equal to, let's subtract 8 on both sides. So we end up with 8, right? So now x is equal to 1. Okay, so x is 1. How do we find the y value? We can, for example, substitute it back into this equation. So y is equal to 2 times 1 plus 4. Okay, so therefore y is equal to 6. So let me label that point, and I'm going to call it m for a specific reason that you might notice soon. So 1 comma 6, okay? So what do you notice here? Well, if you reflect a 3 comma 5 over that point m, right, or over the line, you actually end up with somewhere here, okay? And that's called that a prime. And that's what we're trying to find the coordinates. Now, m is actually now the midpoint of segment a prime, which means that now we can use the midpoint formula to solve for this, okay? So we know that the midpoint 1 comma 6 is going to be the midpoint, right, of 3 comma 5 and whichever coordinate. Actually, let me call this x comma y, okay? So let's write this. So we have 1 comma 6 is equal to, well, the midpoint 1 comma 6 is equal to the x coordinate of a prime plus 3 over 2 comma, and then we know that 6 has to be equal to y plus the y coordinate. In this case, we get 5, right? So that's the 5. And then we divide it by 2, okay? So basically what this means is that x plus 3 over 2 has to be equal to 1. And also that y plus 5 divided by 2 is equal to 6, okay? So we just need to solve for x and y, and then we have the coordinates of a prime. So this becomes x plus 3 is equal to 2. Therefore, x is equal to negative 1. Similarly, we have y plus 5 is equal to 12. And y is equal to 7, okay? So there you go, we find the coordinate point. So that means that a prime is going to have a coordinate of negative 1 comma 7. So let's go back and check if this makes sense. So we have here negative 1 and this is 7. And it seems like it makes sense, right? So that distance is 1 and that distance is 2, okay? What about here? Same thing, 1 and 2. So you can check with the Pythagorean theorem. But anyways, we found a prime in this case in an algebraic way. So that is the answer. So that's basically it for today's lesson. We learned about coordinate reflections. So in the next YouTube video, we are going to learn about point reflections in the coordinate system. Very interesting stuff. So anyways, this was all for today's lesson. I hope you enjoyed it. Please stay tuned and have a fantastic day.